Here is some of your review problems. I'm not going to do them all. The answer key for everything will be posted, but I wanted to walk through sort of one of each type for you. Okay, so looking at this first one, we are finding the asymptotes and stating the domain from a graph. I'm going to start with the domain. The domain, remember, is all of the real numbers. We use that R with the double staff. Except for where the vertical asymptotes are. In this case, there is a vertical asymptote at 4. There's also a vertical asymptote at 0. It's hard to see here because there's no dashed line, but there is an asymptote on the axis. I will be very careful to give you, try to make it clear so that you can see where the asymptotes fall. Okay, remember it's where the graph approaches, gets really close to, but never actually touches. Now for the asymptotes, let's start with the vertical asymptotes. Those again are at the excluded values. So we have one at x equals 4 and we have one at x equals 0. Don't forget that they are two separate lines. They need to be written separately and they do need to be written as lines, as in x equals a number. The horizontal asymptote we can see is at y equals 1. Horizontal again is the side to side. This one does cross it, but you can see that it's marked with this dashed line here. So there is clearly a horizontal asymptote there, okay? Moving on, given a function, we want to state the asymptotes and the intercepts. Now we're going to do this from the function. So let's start with the asymptotes. I'm going to start with the vertical asymptote, which I find by simply finding the roots of the denominator. So if I factor this, I get x minus 5 and x minus 2, which means that my vertical asymptotes are at x equals positive 5 and at x equals 2. My horizontal asymptotes, I look at the degree of the numerator and the denominator. And remember that if the degree of the denominator is larger than the degree of the numerator, we just have an asymptote at y equals 0. Remember, if the degrees are the same, then we take the ratio of the leading coefficients. And if the degree of the numerator is larger, there is no horizontal asymptote, okay? Now to find the intercepts. To find the x-intercept, I am going to set the equation equal to 0, which remember means that I'm actually setting the numerator equal to 0. So I'm going to say if 3x plus 4 equals 0, I would solve that out and I would get negative 4/3. Remember that the intercept is a point, so it needs to be written that way. It's not just negative 4/3, it's negative 4/3, 0. The y-intercept I get from plugging in 0 for the x's, which leaves me with 4/10 or 2/5. Again, a point. I'm going to write it that way. Okay. Describing the end or limit behavior. That applies to the asymptotes and also the positive and negative infinity. So I'm going to do the one on the right because that one has more. The one on the left will only have 4, 2 end behaviors and 2 limit behaviors. But because the one on the right here has 2 asymptotes, it actually has 6. Okay. So we'll start with the limit behavior or the end behavior. As x approaches positive infinity, that's to the right here. F of x is approaching, let's see, 1, 2 from the positive side, okay? And as x approaches negative infinity, that is over here. F of x is again approaching 2 from the positive side. So that's my end behavior. Now I'm going to do my limit behavior. Remember, I need to do that as x is approaching each asymptote from the side. So I have an asymptote here at 1, 2, 3, 4, negative 5. So as x approaches negative 5 from the left, f of x is approaching positive infinity. And then as x approaches negative 5 from the right, that's over here, f of x is approaching negative infinity. Okay, that's my first limit behavior. Now I'm going to jump to the other asymptote, which is at positive 5, and I'm going to do the same thing. As x approaches positive 5 from the left side, f of x is approaching negative infinity. That's the left side there. And then as x approaches 5 from the right side, f of x is approaching positive infinity. So make sure that you're writing end behavior, that's these two, and then limit behavior for every asymptote. Write the equation of f of x equals 5 over x when it's transformed as stated below. So we're going to start with a new function, g of x, and I'm going to have 5 over x, and then I'm moving 3 left, so that's plus 3 here, 4 up there, and then a vertical flip means that I'm making this negative, okay? I'm going to do a new one over here. I'm going to have 5 over x, and then 2 down, minus 2, 7 right, minus 7, and a stretch of 2 means that I'm multiplying that 5 by 2, which gives me a 10, okay? These are pretty straightforward. Just make sure that you're reading carefully to pay attention. And I did do both of those so you could see them, okay? Describe the transformations. Remember, describe means use words. So 3 to x to get negative 3 over x plus 2 minus 9. So first of all, I'm going to start with that negative because I know that that means a vertical flip, okay? We did not talk about horizontal flips. That really shouldn't be an option. A negative in the numerator, which is where I will put it, it means that we have a vertical flip. The plus 2 means that we are moving left 2. And the minus 9 means that we are moving down 9. Okay, so we just use words to describe. And I'll let you do the next one by yourself. We also need to be able to describe a transformation on a graph, and that applies more so to the asymptotes. So first of all, let's start with this one on the left here. Notice that the horizontal asymptote has moved up 1, which means that my function is going to have a plus 1, okay? And it's also moved up 1 because this tells me to both describe and write the function. And I'm going to start with g of x equals, I probably didn't leave myself enough room here. Let's go down here. There we go. Okay, and I know I'm going to have an x here. Now, I've also can see that this is moved right 2, which means that I'm going minus 2. And it looks like there is some sort of stretch because it's not through 1, 1. However, it's not clear what that stretch is. So I would expect you, if you can't tell, you know what, that's not fair. I made it very clear on the test. You'll be able to tell if there's a stretch or not, okay? So if it's at like 1 from the intersection of the asymptotes, or if it was at 2, that would be a stretch of 2. We're going to call this, we're going to leave this as 1 because this is kind of a bad graph. I don't expect you to really know how to do it. That's not very fair. So we're just going to leave it as 1. Now, remember, if there's a vertical flip, it flips to being, instead of top right, bottom left, it's bottom right, top left, okay? So this is not a vertical flip. And let me just write my descriptions here. So we moved up 1 and right 2, and the equation reflects that. Now to come over to this one, this is what I was talking about. This is a vertical flip because it's top left, bottom right. So I'm going to put a negative there, okay? I can also see that the asymptotes have moved left 1, 2, 3.5. So I'm going to call this plus 3.5, and as well up 2. So left 3.5, up 2, vertical flip. And then is there a stretch? Well, it looks like this is, let me count it here, 1, 2, 3. It looks like it's a stretch of 3. So we would put a 3 there, okay? Again, I assume that the values are generally integers, and I will try to give you graphs that match up with that just to make your, I don't want you to get caught up on whether it's 3 or 3.5. That's not fair. The goal is to see if you can tell that it's been moved or stretched or not, okay? So I tried to make it very, very obvious for you. All right, when we are multiplying, we are canceling top to bottom. I'm going to do this middle one. Make sure that you are factoring first, first, okay? Do not cancel until you have factored. That is so very important. And I keep seeing people trying to cancel stuff without factoring first, okay? Please make sure that you do that. You don't want to mess that up. Anyways, so let me get this all factored here. Here we go. So now what can I cancel? I can cancel the x minus 5s. I can cancel an x out of each of these. And it looks like that's about it. So on top, I am left with 3x plus 5, x minus 1. And on bottom, I'm left with x plus 2, 6x minus 1. And that's my solution. Or my simplification, I guess, if you will. We're not solving. Make sure that you factor first. I can't say that often enough. You do not have to multiply it back out either. You can if you really want to take the time, but I wouldn't recommend it. Okay. Division is the same way, except that you're going to flip that second fraction and then factor. Okay. So I'm going to go through and I'm going to factor everything here real quick. Take a 9x out of there. 9x squared, I'm sorry. Factor this. And then this one I'm going to factor on top. So it's x minus 4, x minus 3. And then here, I'm going to take a 3 out of everything, and I'm left with x squared minus 3x minus 10. So x minus 5, x plus 2. Okay? What can I cancel? I'm going to do this in different colors so I can see. So x plus 2s, I can cancel a 3. X minus 4s, and it looks like that is it. So I am left with on top a 3x squared, x minus 3. And on bottom, I'm left with an x plus 3, x minus 5. And there we go. Okay? So don't forget to flip and then factor and then solve. Adding and subtracting requires a common denominator, and sometimes you will have to factor on that one as well. So like this one, for example, I'm going to factor. Didn't really help me because I still have 3 different pieces. Okay, so my common denominator is going to be 3, x minus 2, x plus 2. Which means that this first fraction, I'm multiplying by an x plus 2 and a 3. And the second fraction, I'm multiplying by an x minus 2. Okay? So I'm going to multiply 3 times 5x, which is 15x. And then I'm going to multiply 15x times the x plus 2. And I get 15x squared plus 30x. Okay? Minus, now I'm going to come over here and I'm going to multiply 9x minus 7 times x minus 2. Remember that requires the box, unless you're getting good at doing it mentally, which I hope you're getting there, but it's okay if you're not. Minus 25x plus 14. And there we go. Now I'm just going to combine like terms. I used parentheses intentionally because I am subtracting everything in this second parenthesis, so I need to be careful about my signs. So 15x squared minus 9x squared is 6x squared. 30x, oops, I forgot my x here, plus 25x is plus 55x, and then minus 14, all over 3, x minus 2, x plus 2. Looking at this top, I'm guessing it's probably not factorable, and there's certainly nothing I can take out, so I'm just going to leave that alone. Okay, coming down to solving. Solving is a lot like adding and subtracting in that we have to find the common denominator and multiply by it. So looking at this first one here, again, I'm going to take the different pieces, and my common denominator is going to be a 5 and an x minus 2. Which means that the first fraction, I'm going to multiply by 5. Oh, no. I'm getting crazy here. Sorry. Let me show all the work. I apologize. I'm trying to shortcut and then I'm getting ridiculous. Because I want to show how this cancels, okay? So again, if you don't need to show all of this, that's fine. But I'm going to show it here so that you can actually see this as you're reviewing and figuring stuff out, okay? So my x minus 2's cancel, and I'm left with 5 times x, which is 5x. Here my 5's cancel, and I'm left with 1 times x minus 2, which is just x minus 2. And here my x minus 2's cancel, and I'm left with 2 times 5, which is 10. Okay, now I'm just going to go through and I'm going to combine like terms and solve, and I get x equals 2. But remember, you need to check that back up here, because when I plug 2 in, I'm going to get 2 minus 2, which is 0, which means this is an extraneous solution. So there is no valid usable solution for this problem. So even though we did all of the solving right, don't forget to actually check and make sure that this doesn't create a zero denominator. Okay, that's really important. Let me do one more for you here. I'm going to do this one on the right. When I factor this, I'm going to get x plus 5 and x plus 8, which is my common denominator. Okay, so that's what I'm going to multiply by. And I'm going to leave it in its factored form because that's going to make it easier for me to cancel when I go to do stuff. So let me write all this out here so that you can see the work that I'm doing. Again, remember that you don't have to show all of this. However, remember that the more work you show, the more likely you are to get points on your test, because I can see where you're going, okay? I didn't write this last one out. Number one, I ran out of room. But number two, the x plus 5 and the x plus 8 are going to cancel, and I'm going to be left with just 7. So I'm just writing that for the sake of space and time. So I'm left with 5 times x plus 8, which is 5x plus 40. And then here the x plus 8's cancel, and I'm left with minus 3 times x plus 5, so minus 3x minus 15. Watch your signs. That's really important. It's a negative 3 times both of these, okay? So make sure that you distribute that out. And then when I got over here, these were going to both cancel out, and I would just be left with 7, okay? Now I'm going to solve, and I get 2x plus 25 equals 7. 2x equals negative 18, so x equals negative 9. And if I put negative 9 back in here, I am not going to get 0 for either of those. Negative 9 plus 5 is negative 4. Negative 9 plus 8 is negative 1. So I am good. This is a valid solution. Okay? Hope that helps you. If you have any questions, you are welcome to let me know.